Alcohols have an hydroxyl group in them, and that hydroxyl is polar, so that hydroxyl group is going to influence the properties of alcohol. So let's look at its impact. So on this slide here, we have an electron density map of 1-propanol, and wherever there's more red, that means there's higher electron density. So the oxygen in the hydroxyl has a partial negative charge, and we remember from way back when in Chem 151 that oxygen is a highly electronegative atom. So this polarity is going to influence some of the properties. Now, straight chain alcohols with up to 12 carbons are going to be liquid at room temperature, and methanol and ethanol are miscible, so that's a word that means soluble for two liquids, with water, and the methanol and ethanol can also dissolve small amounts of ionic compounds. And both methanol and ethanol are miscible in many organic solvents. Now, all alcohols are going to have a hydrophilic part, which is going to be the hydroxyl group, as well as a hydrophobic part, which is going to be the nonpolar alkane part. So methanol has a small hydrophobic part or small nonpolar part, and so therefore it's more like water, whereas 1-heptanol has a much larger hydrophobic or nonpolar part, and so it is going to act more like an alkane. And just to help you remember, philic means loving and phobic means fearing or hating. So hydrophilic is going to love water, it's going to be polar, and hydrophobic is going to hate water and therefore be nonpolar. Now, here in your textbook, there's a general rule of thumb for solubility of alcohols, and in general, organic molecules, and this works for other molecules other than alcohols, but definitely for alcohols, organic molecules having a carbon to oxygen ratio of 1:1 to 3:1 are soluble in water, such as methanol, 1 carbon, 1 oxygen, ethanol, 2 carbons, 1 oxygen, propanol, 3 carbons, 1 oxygen. They are soluble, while those having ratios of 5 carbons to 1 oxygen and greater tend to be insoluble, whereas 4 carbons to 1 oxygen is sort of the line between insoluble and soluble in water. Now, diols, or alcohols with more than 2 OH groups, can form more than 1 hydrogen bond, and therefore they're going to have higher boiling points because they'll be engaging in more hydrogen bonding and have higher intermolecular forces, and they're also going to be more water soluble than similar alcohols, and by similar I mean same number of carbons, with 1 OH group. So let's compare 1-butanol. It has a boiling point of 117 degrees Celsius and a solubility of 7 grams per 100 milliliters, whereas 1,4-butane diol has almost double the boiling point at 230 degrees Celsius, and it is completely miscible, which means it completely dissolves in water.